We're UofL, and this is our submission to the American Makes Additive and Steel competition.
So we began our design process by researching traditional multi-tools. We wanted to do something similar to this, but simplify it to make it easier for additive manufacturing. So we started looking at tools like this, which are just pure functionality, nothing extra, but we didn't want quite that simple. So we looked at a combined one-part tool, such as these fencing pliers, that already had a hammer, a hex wrench, pliers, or a pry, and operated with intuitive plier action. So initially we planned for some modularity with reversible tool ends, but we eliminated that idea for simplicity. This was the first basic geometry that we decided on. Basically, we have our hammer over here, flathead, hex wrench, wire cutter, socket receiver, seatbelt cutter, bottle opener, Allen key, and Phillips. We decided to combine some functionality, so our Phillips head was going to be our glass breaker. Our flathead would also be the pry. The way we were thinking about designing the seatbelt cutter was print the basic geometry with a cavity, put an off-the-shelf razor, and then seal over the top. Over here, there's some more details. We decided to rotate the socket receiver so that it would be self-supporting as it printed. We also used a self-supporting dovetail geometry for this hinge so that the two halves of the tool would print interlocking.
So to take our ideas off of paper and onto CAD, we set out to make a few different designs. This one focuses mainly on the hammer, whereas this one focuses on this seatbelt cutter aspect of the design. And then this one takes care of everything else. So our goal was to take all these ideas, put them into one part. So we combined all of the aspects into one part, and this is what we came up with. It fits within the 3.5 and 6.5 requirements for the tool size. So the next step from here is to perform some FEA tests at some critical locations.
So we also did FEA simulation using SolidWorks, and we applied a 40-pound force on the split faces to mimic the turning force, and we found out that the deformation was negligible. So during the simulation, we were interested in finding out whether our tool would fail. So we applied a 40-pound force toward the top and the bottom over the inner side and the other side. And we also found that the deformation was negligible. That proved that our tool will survive everyday usage.
So we made a few modifications to our FDM printed part so that we could print it in metal on our EOS machines. We made this test print so that we could benchmark certain design features.
So this is the first benchmark part that we printed. It's got a noticeable warp to it due to built up thermal residual stresses. As you can see on the socket receiver, that warpage caused a deformation that threw the dimensions off, and the same thing happened on the Allen key.
Additionally, we printed benchmarking parts to test various spacings for the print-in-place hinge. Many of these parts failed, which gave us valuable insight that would help us in our final design of the multi-tool project. Various additional changes were made to the final design, including reorientation of the flathead screwdriver to act as a better staple remover, and reorientation of the socket extension receiver. The final design of the multi-tool project incorporates lattice structures to reduce the overall cross-sectional area of the multi-tool design. This eliminates internal built-up stresses from the laser powder bed fusion printing process, as well as decreasing the overall weight of the multi-tool due to the lower density of these sections. With the design complete, the multi-tool is prepared for fabrication in the EOS M280. Additional processes were completed using our Beam Modulo 400 DED machine and Fanuc wire EDM. After additional post-processing, the multi-tool was tested to make sure it met all of the requirements of the American Makes competition. The socket receiver, Phillips head screwdriver, and Allen key all performed their tasks very well. The adjustments made to the flathead screwdriver greatly improved staple removing performance, and the bottle opener works very well due to the print-in-place hinge. Thank you to American Makes for the opportunity for us to compete in this year's competition.